learning target 15 is graphing systems of inequalities of conic sections. So in order to do that, you have to be able to graph all 4 types. So all that stuff you've forgotten, you have to remember it again, because you have to be able to graph them all. Okay? So we're going to go through quickly all 4 types of conic sections. Again, how you tell the difference between them and what you need to graph them. All right? Because you have to be able to graph them. That's the whole entire point of the learning target. So first type of conic section should be the easiest one and should be the easiest one to graph. And that's a circle. You have standard form where you have x minus h squared plus y minus k squared equals r squared. If you're going to graph a circle, what 2 things do you have to have? Center and the radius. Right? Center is hk. The radius is whatever the square root of that number is. All right? If you're going to graph that, you graph the center, and then you just count in all 4 directions. You count the radius, and then you draw a circle. Right? So those should be pretty easy. So to graph that, we need the center and we need the radius. And you can use the red sheet, but the red sheet doesn't tell you how to graph everything. It gives you the equations. So that's about it. Questions about circles? All right. Parabolas. We just talked about. That was the last set of learning targets we did before the last quiz and test. So how do you tell it's a parabola instead of a circle, ellipse, or hyperbola? Okay, there's a 4p in the equation, and it only has 1 squared term. So you have just x squared or just y squared. You don't have both of them squared. Those should be pretty easy to pick out. Okay? Now to graph a parabola, you need to know some things. You need to know the vertex, right? That's HK. So into the vertex. You need to know if it's horizontal or vertical, right? If you have y squared, that's horizontal. If you have x squared, that's vertical. Right? So you have to know which way it's going to go. And then P should tell you which direction it opens. So if it happens to be horizontal, if P is positive, does it open right or left? Right? And so if it was negative, it would open left. Same thing for vertical. If it's positive, it opens up, and if it's negative, it opens down. Okay? So you have to know those things. So you mention the vertex, if it's horizontal or vertical, and then if P is positive, that means it opens up or right. If it's negative, it opens down or to the left. Again, we're still just eyeballing the parabolas. I'm not making you find the specific points past the vertex. So just be careful today when we're graphing these when you're looking at test points and things. When you were graphing an ellipse, I told you you had to know 4 things. So what are some of those 4 things you have to know to graph an ellipse? The center. So you still have the center, HK. What else do you need to know? What A and B are. And then you need to know if it's horizontal or vertical, right? And an ellipse, remember A is always bigger than B, right? Because the fractions could be in any order. So if A is bigger and it's under X, it's horizontal. If A is bigger but it's under Y, that means it's vertical. So keep those things in mind. So again, you need the center, if it's horizontal or vertical, and A and B. So here's your 4 things you need. But some things to remember, A squared is always bigger than B squared. So if the A squared is under the X, it's horizontal. If it's under the Y, it's vertical. If you're going to graph that, you graph the center, and you just count out A from each side. If it's horizontal, that means you're going left and right. If it's vertical, you're going up and down. And then B, the opposite direction. So it's similar to graphing a circle. Questions about an ellipse? And a hyperbola. You should be able to figure out what's a hyperbola really easily because you have two square terms and there's a minus sign in the middle. That's important. What do you need to know to graph a hyperbola? Horizontal or vertical. Still need to know the center. You need to know A, because from the center to from A over from the center is the vertex of each branch. And then we were using the asymptotes. I'm going to shortcut that today by finding B. If you know A and B, you can draw in that imaginary box, and the asymptotes always go through the corners of the box. So you don't have to actually find the equations of the asymptotes to graph those in. Right? That way you know how wide the branches are supposed to be. So today you need, again, the center, if it's horizontal or vertical, A and B. A is always first. A doesn't have to be bigger anymore. So if X comes first, it's horizontal, and if Y comes first, it's vertical. Again, given that the minus sign is in the center. So we've done all these things. Now it's just having to recall all of them at the same time. Any questions so far? We're graphing inequalities, so just like when you graphed inequalities before with other concepts, similar ideas still happening. So in Algebra 1, when I taught you about graphing inequalities involving systems of lines, all right, if it had a less than or greater than symbol, it was a dotted line or a dashed line. And if it had a greater than or equal to or less than or equal to symbol, it was a solid line, right? That still applies. That's still a thing. Okay? Again, solid means that those values are included in the solution set, and if it was dotted, they weren't. Okay? So that's still a thing. Okay? Then, I don't remember if in Algebra 2 you did any systems with quadratics or not. I don't think you did inequalities. You might have done systems of quadratic equations, but not necessarily systems of inequalities. I don't recall. So here's kind of the procedure you're going to go through to do all these. First thing you're going to do is identify what type of conic section it is. Because if you don't know what kind it is, you can't do anything. So you have to start by figuring out what it is. Once you figure out what it is, you want to put it in standard form so you can graph it. Once you've graphed it, you want to make some note to yourself about where you're going to shade that one specific conic section. Some of those are easier than others to figure out, so we might need to use test points, and that's okay. Then you'll graph the second equation. Again, figure out what it is, put it in standard form, and graph it. Figure out where you would shade that section. Again, for a system of inequalities, the shaded portion where they overlap is a solution set. So you find where the shaded portions overlap. Okay? It's going to be fine. All right. Questions so far? It's going to be fine. All right. The first example. We have two equations or inequalities that are in the same format. So that means both of them are the same conic section. What are both of these inequalities representing? Circles. How do I know that they're circles and not ellipses? They're equal 1, but there's also nothing in front of the x squared or the y squared. I don't have to divide out or anything, right? We just have x squared, y squared, and then an r squared, right? So we have circles. Remember, a circle is just a special type of ellipse. So if I rewrote it as an ellipse, it wouldn't be the end of the universe. I would still get the circle, all right? Because A and B would be the same. So these are circles. They're both already in standard form, so that's nice, because that means I don't have to do anything extra to fix them or anything. So let's start with the first equation, or first inequality. I keep calling them equations, they're inequalities. What is the center of the first circle? 0, 0. And what is the radius of the first circle? 10. On the circles quiz / the first test in the unit, some of you guys would forget to take the square root of that number. And so you would tell me that the center, or the radius was 100. Be careful that you take the square root. Okay? All right, so we're going to graph this. We put a point at 0, 0. And then we go and graph a point 10 out in each of the cardinal directions. And then I'm going to cheat and draw a circle with my circle tool, and you guys are going to do the best you can. This is a solid line because it says less than or equal to. Now, before we move on, we need to decide where we're going to shade. Because if you start trying to graph both of them and then go back and figure out where you're going to shade, then it gets confusing. So I would say graph one, figure out where you're going to shade it. Then graph the second, figure out where you're going to shade it. This one says x squared plus y squared is less than or equal to 100. So where do you think you're going to shade? Inside the circle, because this is less than or equal to. Circles are kind of easy in that way. If you weren't sure, that's fine. Use a test point to figure out. So if I was going to use a test point, the easiest test point to use is 0, 0. If I put 0, 0 into that equation, I get 0 squared plus 0 squared is less than or equal to 100. Is 0 less than or equal to 100? Yes, so I would shade inside the circle because there's a point inside the circle that makes that statement true, right? So I know that I'm shading inside the circle. You have two options. You can shade inside the circle or shade inside whichever conic section, whatever you're doing, just to make sure you remember. Or you can write it down somewhere. Again, the final answer is just going to be where the shading overlaps. So that's up to you. So if you just want to put some like bars through it to make sure you remember, that's fine. I wouldn't go through and like deeply shade the whole circle since we're going to have another circle in a second. Okay? But if you need to mark it so you remember, that's fine. Questions? All right. The second circle. X squared plus y squared is greater than or equal to 25. What's the center of that circle? 0, 0. And what's the radius of that circle? 5. And so start at 0, 0. We go out 5. This is why I suggest you don't super shade in the circle before, because you still need to be able to see. And then I'm going to cheat and draw a circle. This is still greater than or equal to, so we still have solid lines, solid boundaries. Now this one says is greater than or equal to 25. So where do you think you're going to shade? Inside the circle or outside the circle? Outside. If you weren't sure, use a test point. You can use 0, 0 again. 0 squared plus 0 squared is greater than or equal to 25. Is 0 greater than or equal to 25? No, so you can't shade inside. All right? So we'd be shading outside the circle. So outside the circle would be everything outside that circle. So for the system, for the system of inequalities, what am I really supposed to shade? Right, in between. It makes like a donut or a ring, right? So if you've already shaded, that's fine. I just need to make sure that you identify somehow that the solution set is inside the ring. So darken that part more, make that a crazy pattern, I don't know, something. But that is the solution set, is everything inside the donut. Any point inside here will make both of these inequalities true. Any questions about how I did that? Again, identify what it is. Graph one conic section. Figure out where to shade that one. Then graph the other. Figure out where to shade that one. And then identify the overlap. Questions on the first example? That one wasn't that bad. Just 2 circles. This is fine. All right, questions about that one? Then I'm going to erase all of this. And we're going to do the second example. All right, on the second one, what are both of these inequalities representing? What conic section? And how do you know? Parabola, and how do you know? There's only one squared term. Unfortunately, neither of these are in standard form. So we're going to have to do some work first. Let's start with the first one. If I want this to be in standard form, what has to happen? You have to get the y squared by itself, so I have to subtract x. I'm going to write it as negative x plus 9 because we like to have the x in front, right? Still not in standard form, though. We have to have a positive x with a negative x. If I want a positive x, I need to factor that negative 1 out. Right? Have to have a positive x. And dividing by a negative would change the y squared to be negative, and that wouldn't help me either. Then I'm supposed to have 4 times p. So if you don't know what it is, you can set up a really quick equation, 4p equals negative 1, and you can solve for p. Or you can just think it through, whichever works for you. So what is p in this scenario? Negative 1/4. So from this, I know p is negative, so that means it's going to open left or it's going to open down. Just depends on if it's horizontal or vertical, right? So with the y squared, is this horizontal or vertical? Horizontal. Because it's horizontal and p is negative, I know it's going to open left. The only other thing I need to know is the vertex. So what's the vertex? 9, 0. Remember, this is h, and then k would be over here. And it's obviously y minus 0 squared. Any questions how I figured those 3 things out? We graph the vertex in, 9, 0. We know it's going to open left. I have never made you guys have to figure out the exact parabola. I'm not going to make you do that here. So we don't really know how wide it is. We know it's going to open left. Whatever you decide how wide it is, you need to make sure, though, you extend that all the way out to the side of the graph. Why am I making you do that? But we're going to have some boundaries, right? Where we're shading and stuff. You can't just have this little teeny, like on your quizzes, you're doing like these little teeny parabolas like this, which is fine. But then we can't shade anything, right? So we're going to have some boundaries. Is that necessarily the right, correct width of the parabola? Probably not. That's okay. We're just eyeballing it at this point. We need to decide whether or not we're supposed to shade inside that parabola or outside of it, though, before we move on to the next one so we don't get confused. It says that y squared is less than or equal to, but that's not necessarily helpful. It's not like a circle because it's open on one side. So if you get confused, here's what I advise you to do. You're still using a test point. But since you don't know how wide it is, all right, I would make sure you pick a test point on the axis of symmetry because the points on the axis of symmetry are always going to be inside the parabola, right? So that way you don't pick one that might have been inside and might have been outside depending on how you graphed it. Lucky for us, in this case, 0, 0 is inside on the axis of symmetry. So we're going to plug 0, 0 into the equation to figure out if we shade inside or outside. That's going to be my test point. So if I plug that in, 0 plus 0 squared less than or equal to 9. Is 0 less than or equal to 9? Yes, so that means I'm going to shade inside this parabola. So again, if you need to mark that, you can do that. Just don't do it heavily because we're going to have to graph something else here in a second. Questions so far? Can I erase all of the work I've done for the first one? Yes, no, maybe. For the second one, not in standard form either. So what needs to happen to put it in standard form? Subtract y. And we have to have a positive y. Just like last time, the negative 1 is supposed to be 4 times p. Last time it was also 4p was equal to negative 1. So p still equals negative 1/4 in this case. X squared is a squared term, so is this horizontal or vertical? Vertical. And since p is negative, does it open up or down? And what is the vertex? 0, 0. So 0, 0 opens down. So again, just eyeballing those, right? We need to pick a test point on the axis of symmetry. You cannot use 0, 0. Because it's the vertex. So that doesn't tell you anything, right? It's on the line, so that can mean you shade inside or outside. It doesn't help you. So pick any test point you want. I'm just going to pick one like 0, negative 1 maybe. Something on the axis. Doesn't matter. You pick. So again, as long as it's on the axis of symmetry, it's always going to be inside the parabola. So if I use 0, negative 1 as my test point, I have negative 1 plus 0 squared. Is negative 1 less than or equal to 0? Yes. So I'd be shading on the inside of this parabola as well. So that would be in here. So that means the solution is inside this little section. The solutions are all within that little section. Again, we're probably going to be off a little bit because I'm not making you guys find the exact parabola, but it's a sketch. So that could be a little bit wider, a little bit narrower. We don't really know. You don't have to go back and erase all of your shading, again, as long as you darken the part that is where it overlaps. Questions about that one? Okay. We've got one more. Now this time we have two different conic sections. So the first one, what type of conic section is this, and how do you know? It's an ellipse. It's not a circle because of the 4, right? You can't have a number in front of the x squared or the y squared if it's a circle. It has to just be x minus h squared plus y minus k squared. It can't be 3x squared or 7x squared. You can't do that for a circle, okay? So because of that, we have an ellipse. Because we have something squared plus something squared. That means it's not in standard form. Because an ellipse has to be equal to what? 1. So that means I need to divide this entire thing by 16. So we have x squared over 16 plus y squared over 4 less than 1. As a side note, it might come up in your homework once or twice, I don't recall. If you were going to divide by a negative number per chance, what would you have to remember to do? flip this inequality symbol. Just making sure I said that out loud so everyone thought about that. Okay? So, remember an ellipse, A is always bigger than B, right? And so whatever the larger number is under makes it horizontal or vertical. So 16 is bigger than 4, and 16 is under the x, so it's just horizontal or vertical? Horizontal. What is A and what is B then? 4 and 2, and then what is the center? Those are the 4 things you have to have in order to graph it, right? So, this is the first time this has come up today, so make sure you're careful. It says less than 1, so when you draw your ellipse, it's a dashed boundary, okay? So I've got 0, 0 is the center. A is 4, and it's horizontal. That means I count out 4 to the left and to the right, because that's supposed to be longer on the horizontal axis. So 4, and then 4 this way. If it was vertical, we'd go up 4 and down 4. Remember, A is always longer. It's horizontal. That means it has to be longer horizontally. B is 2, so that means you go up and down 2 from the center. And then again, we're going to make a dashed boundary. Ellipses are like circles, and I think it's easier to figure out where it's just a shade, but by looking at it, it says it's less than 1, so that means you're probably going to shade inside. If you weren't sure, you can use a test point. 0, 0 is right there in the center. So if you did that, 0 squared plus 4 times 0 squared, is that less than 16? Well, yes, 0 is less than 16. So you are shading inside of the ellipse. I'm going to erase that because I've got some stuff to add into here in a second for the next part, so I don't want to get too confused. All right, questions about how I got the ellipse? How I got all those pieces? All right, next equation then. It's probably going to be easier to identify this if we get the x squared and the y squared on the same side. So how do I accomplish that? Subtract y squared. So I have x squared minus y squared is less than or equal to 4. So what kind of conic section is this? A hyperbola, because there's a minus sign. Is it in standard form now that I've subtracted y squared? No, because it's got a 4 and there has to be a 1. So make sure you divide that by 4. And a hyperbola. A is always in the front, right? As long as the minus sign's in the middle. And if x is in the front, that makes this horizontal or vertical? Horizontal. If x is in the front for an ellipse, or x has a squared under for an ellipse, it's horizontal. X squared is in the front for a hyperbola, it's horizontal. What is A and what is B? They're the same here. 2. And what is the center? 0, 0. Now, generally, we have to graph the asymptotes. I'm going to shortcut that today for you. Okay? We're going to start by graphing the center, and then we're going to graph that imaginary box. Remember hyperbolas have that imaginary box in the middle? Right? If I graph the imaginary box, then I can graph the imaginary asymptotes, because they go through the corners of the imaginary box. Okay? That way I know how wide those branches are supposed to be. So 0, 0, it's horizontal, so technically I would go out 2 and out 2 to find the vertices. So this is a vertex of the hyperbola, and that's a vertex of the hyperbola. And then up 2 and down 2. So that means that imaginary box is right there. right? Now before I made you find the equations of the asymptotes, and you had to fill it in. It was y minus k equals plus or minus, and it was a over b or b over a, depending on which orientation it was, times x minus h. You could still do all that, but that's a lot of work when I know they go through the corners. So I know that the asymptotes go through the center and then through the corners of the box. And those are there to help us figure out how wide those branches are going to be. It's a horizontal hyperbola, so now I can draw in the branches. They hug the asymptotes and go through the vertex. All right, let's not forget we have an ellipse here in the center. So I'm trying to get rid of that square shape so we don't worry about the square. For the hyperbola, it says less than or equal to 1. So either you're shading everything inside the branches, that hourglass shape, or you're shading everything outside the branches, which would be the two kind of parabola shapes inside those, right? So if you're not sure, use a test point. 0, 0, again, is right in the center. So if we use a test point, 0 squared is 0 less than 4. Yes, so I'm shading inside the branches. So technically, if you're showing a hyperbola by itself, you would shade everything inside this hourglass shape. Okay, that's inside the branches. Now, we already said earlier we were supposed to shade inside the ellipse, right? So the intersection of the two is this little section in here. It's got like a inverted like football shape. It's not a square. Questions at the moment?